So my name is Allyn Hunt. I'm here to talk about powering up your Python web applications. So about me, I started kind of playing around with Python about 3 years ago. I started playing with Raspberry Pis, Arduinos. I play a lot of video games, so I started using Python as a way to play around with the Destiny API for Destiny the video game. And once I kind of got a bit more into it, I started blogging about it. So from that, then I've built a couple of websites. So I've built DestinyVaultRaider.com, which is it's an inventory management system for Destiny the game. So hopefully I'll be able to show you some of that as well. And I'm going to talk a bit more about Python web applications, but mainly kind of Flask orientated, because I think Django gets a lot of love, but Flask kind of gets left out of it. And actually a lot of the stuff Miguel was talking about earlier, I actually learned this from Miguel's book. So if you've read Miguel's book or done these tutorials, you'll see a lot of it kind of recycled here. So it's kind of hard to explain what Destiny Vault Raider is, because you need a game account to actually get access to the website. But you can see on the left-hand side here, this is the inventory management system I've been working on. And on the right-hand side, every kind of page or every kind of view of Destiny Vault Raider has a corresponding blog post. And it basically, you know, it's kind of geared towards people like me who are community developers for the game, who can see what other people are doing and I suppose try and understand how to use the API and how to kind of build their own websites. I spent a lot of time working on this myself, and I felt like I was hitting my head against a brick wall. So I thought it'd be nice to have a resource for other people to actually kind of see how these things are done. So hopefully, if I'm lucky, I'll be able to play a video too, and we can see what it looks like. So I don't have a mouse here, so yeah, it looks like it's working. So that's Destiny the game here, and this is my app on the laptop. So I've stored one of my helmets in the vault, so you can see that I've transferred the helmet to my character, and now I want to equip the helmet onto my character. So I go back to my view, click on the helmet, and my helmet changes. So I'm going to do some player versus player here, so I want to put my best weapons on. So if I go back to my vault and I transfer across Media Multi-Tool, which is one of the best guns, and since I'm doing a bit of player versus player, I want to transfer a sword across as well, because player versus player is just more fun with the sword. So you can see here. So I'll transfer it across, and you can see it appear there. When I was transferring the gun, you can see the gun appear on his back, but the sword won't appear on his back because he's obviously carrying a gun already. So that's the web app itself, and you know, I've a couple of other apps like that I'm not necessarily going to talk solely about how I built that, but a lot of the oops, is that still presenting? Yeah, there we go. So a lot of it is kind of built on that. So what I am going to talk about, I suppose, is the structure of the app. I'm going to talk about adding some asynchronous tasks with Redis and Celery, and why I added them and how I added them, and then adding a React front end. A lot of the examples here, again, they're in Flask, but they're very portable to Django, especially the front end stuff. A lot of the stuff that the app structure is stuff that's kind of built into Django by default, but by Flask you have to kind of build it up piece by piece as we go on. And again, so the app structure side of things, I'll talk a bit about the Flask Application Factory. So a lot on the Flask Application Factory, using Flask scripts or Flask CLI, and separating your app into blueprints. You know, there's a lot of online resources and tutorials on how to do this, but it's not very clear as to why you should do it. I think when people start off kind of working with Flask, they end up with something on the left with their app.py, because it's such a lightweight system, you can get it going in one file. But just because you can build it in one file, it doesn't necessarily mean that you should. But I think a lot of the details gets lost on people as to why they should invest time refactoring their code when it's working with one file. So I'll have a look at some of the database stuff that I'm working on at the moment. So this is the Flask App Factory, and essentially what the App Factory is doing is it's using a function to create your app. And the there's some very subtle differences here. So you can see on the left-hand side, we're adding a database, which is SQL Alchemy. On the right-hand side, we're doing something a bit differently. We're defining the database as a global, and then we're calling db.initApp. So what does this do? Well, according to the documentation, it doesn't bind the database to your app, which is a bit of a strange thing. Why would you not want your database bound to your app? It sounds like a good thing. You know, I can access my database from my app. Well, the reason you don't bind it to your app object is so you can use the database in different contexts. So you can separate the database from your request context altogether. And again, this is stuff that's kind of taken for granted, I think, in Django as well, where you use your CLI tool here. So here what we're looking at is on the top is I'm using my manage I'm in the shell context, and I can access my database. So you can see here if I do files.query.all and print, I have found 4 files. And on the bottom, the only difference here is I'm switching to my Flask config environment variable to production. So what that's actually doing in the background is it's actually connecting off to a server, to my Postgres server. And you can see here I've got 46,000, nearly 50,000 files on that server. Again, a lot of this is kind of taken for granted in other kind of bigger web structures. But Flask is kind of, it's so modular, you don't necessarily need to build this into your app unless you actually set about doing it on purpose. So, and again, I'll just go back here. This is important because we've actually now separated our database from our HTTP request. So we don't need to wait for someone to actually send a request to our server to access our database. We can now access it completely separately. So essentially what you can do is, in this instance here, I had a bug in my code which was more of a feature really. I'd like to think of it as a feature, but it meant that everything older than 1 day had to be deleted out of the queue system database here. So if you've ever tried to do that in PG admin or one of your database admin tools, it's pretty difficult. But however, you know, by separating the database context out, it was pretty trivial to do it. So you can see here for queue and job queue, db session.delete, everything in queue. If the time to live in that item is greater than 10 hours. That's a pretty simple example, but if you're looking at, for example, if the job queue had a bunch of relationships added up to it, so each job had many files added to it, then you'd have to kind of step down through all of those relationships and try and figure out what you were deleting there. So it's pretty trivial to actually build up those relationships by importing the SQL database outside of your Flask web application. So I think the kind of important takeaway from this is we have a web application, and now we can use that web application in a different context to access our database. So let's say if we have our web application here, it's hosted on some sort of platform as a service or a virtual private server like Heroku or your own VPS. It's connected to our Postgres SQL. What we can do is we can do a git pull and put that code onto our server. And now we can have local access to our local server. So all these files in our local Ireland server here, we can use that context, write scripts, and we can parse log files. We can do whatever we want on that server, push everything to a database, and then we can view it on our Flask Web Server, which it wouldn't have been possible before because the Flask Web Server doesn't have access to the files in Ireland. Any of the files in Ireland, we would have had to kind of build a custom database parser to actually push it to the database. But this is actually the same code in both instances. It's it's a couple of lines different. I think we all know how to open and parse a file in Python at this stage, so it's a pretty powerful tool. And from that then we can add multiple sites onto that. So we don't necessarily need to have our web server completely isolated. We can have the same code. In this case, the code I think was 50 megabytes. It was running across 3 different geographies. Scraping databases, scraping log files. The web server served as kind of a job queue, so people could go in and add their jobs to the job queue. So you can see here, Allyn Hunt on the Ireland server. I want to parse this log file, and I've given it some unique names like run1 log file and experiment1 results. So a cron job runs on the Ireland server and it reads all of the jobs in the job queue and it says, okay, hang on a sec, I've got a specific job for the Ireland server, and then it'll go off and run that application and post all the results back into your database there. So how do we write the code for that? It's pretty easy now that we've actually separated our database model from the Flask Web Server. Oops. So the usual stuff. So for map import, our create app function, so we can use the Flask database. For models, import users, files, queues, whatever models you have. So this is important again because you've already spent a lot of time investing in your web application. You've built up all your database models. You've built the connection to and from your database. You want to be able to reuse that code as much as possible. You don't want to have that code isolated up on a platform as a service, just running away. Like you invested all that time on that code. You want to be able to reuse it. And again, so this bottom line is a Flask specific thing. So we're pushing the app context. So this is essentially saying we want to execute the app in this context, which will be this kind of the CLI context. We're separating it away from the web server context. And with those kind of 3 lines of code, really we have access to all of our databases on another server. So my queue equals queue.query.all, so we can easily pull data from the database, parse it through it. We can add data to the database with just a couple of simple lines of code. So it's a pretty powerful tool, but again, it's something that seems to be glossed over on any kind of documentation you see. You don't need to add this up front, but then again, for the sake of 20 or 30 lines of code, you've got a really powerful tool here. You've got all that code that you can reuse working on both your server running in the cloud or wherever it is, and your local server that's kind of parsing log files. Kind of in this situation, so I'll take you back to Destiny Vault Raider again. I didn't really have the option of kind of connecting multiple servers to it, but one of the big dependencies I did have was every time Bungie, who were the developers for Destiny, would release a new manifest file. That's a big JSON file. It's I think about 80 megabytes of JSON data. I'd have a very strong dependency on my web application. So whenever they'd release an update, it would break all the links to the pictures or all the item names or anything like that. So when a user would come to my website, and I would generally track who was coming to my website and what was happening. So I could see a user has come to my website and they've hit a 500 internal error because the manifest has just been updated a couple of hours before. So we didn't have any kind of warning as to when the manifest was being updated or how often it was being updated, sometimes once or twice a week. So this was the kind of solution to that issue. So I stored the manifest file into a Redis database here. And you can see here, there's a couple of things going on in this diagram, so I'll talk through them. So it's a Flask application. The Flask is connected to a Redis message broker. And again, because I had the database stored in Redis, it made sense to use a Redis message broker. The workers are Celery, so I have an asynchronous and a periodic Celery task. Just waiting, the periodic task would run every 5 minutes, I think, and the asynchronous task would wait for someone to visit a private endpoint to kick off the task. And here's the app structure for that. Oops, sorry. Here's the app structure for that. So you can see, again, it's not a huge difference to the large application structure that you would be familiar with. So I have a couple of different files. Celery Worker, I've updated the config a bit. I have the get manifest that actually does the get of the database. I've updated the 2 init files. It's so nothing spectacularly different. I haven't had to invest a huge amount in changing the infrastructure of my application. So if we want to use Redis, the first thing we have to do is connect to the Redis database. And we do that by setting an environment variable called Redis URL, and it's read in. So we get the host, the password, the port, everything from a URL. There's other flavors of Redis actually there. So one of the things you will notice here is that this version of Redis isn't very compatible with Flask, so I can't push it onto the app context like I did with my previous database. But that was basically a limitation of me developing on Windows. So there are other kind of flavors of Redis. There's Flask Redis, Flask and Redis, which is another library, and there's Redis Q. And actually, Miguel, who was speaking in next door, did some tutorials on using RQ and Celery as well. So they were a good starting point for me. So once I have the config set up, I can connect to the Redis server, and you can see here it's Redis db.ping, Redis is connected, or else print out the connection error. Hopefully we don't see a connection error. And then create a Celery worker. So we have the Redis connection sorted out now. The Celery worker also uses the Redis URL, so that bit is pretty straightforward. In the init app, we create an instance of the Celery class, and we add the Celery configuration to our app. So you can see there Celery config.update app.config. So we're taking any of the Celery config, like the broker URL, excuse me, the broker URL, and we're adding it to the app. And then Celery worker, we're just adding the app context push. So we're just pushing the Celery worker onto the app context like we did before. So how do we create a periodic task? So first of all, we have to create the schedule for the task. And so on top we can see the Celery schedule. So the schedule name is app.getManifest.periodic run getManifest. It's a fairly intuitive name, I think. But what the name actually breaks down to is app is the app folder, getManifest is the file that this periodic task is inside, and the function that we want to run is called periodic_run_getManifest. And that's basically it. Once you have that, and you execute your Celery worker. And again, on Windows, this has to be done on 2 different command lines, but you can see the worker-a, Celery worker, Celery beat-a. On Linux, you can kick off your Celery worker and your Celery beat, which is your periodic task, on the one line, but on Windows, you need 2 commands. And we can see from the output here that when this task is running in the background, so we have a window up with the output of the Celery worker. You can see it's received task, app.getManifest, starting new HTTPS connection to bungee.net. And here's me printing out, I've detected a change in the version number, starting new HTTPS connection to Slack. So I normally send myself a private message on my Slack account when something happens, and detected a change in mobile world content paths, which is the actual, it's an SQL-like database that Bungie have updated, and it's the English version of it. So right there, that code has solved a huge problem for me, because that runs in the background on my server now, and every 5 minutes it pings the Bungie servers and checks for the latest version of the manifest to see if I have it. Whereas otherwise I was kind of manually going in checking it, or waiting for a Slack message to say a user has gone onto your website and hit a 500 error. And again, creating the asynchronous task. So this is a bit of a eye test here, so apologies about that. So the first thing we do here on the app.getManifest is we check the manifest version. So we request the manifest version, check the version. If the version is greater than the previous version, then we get the manifest. Else we do nothing, because no change has been detected. On the get manifest code itself, we define the asynchronous task, and we execute the task via a private endpoint. So I have a blueprint here with an API route. So this is essentially an API view that's been locked down to only myself, which I've omitted some of the code to make it a bit more readable. But all we do then is we run the asynchronous task. And you can see here on top of the asynchronous task, the only difference really between the definition of the asynchronous task is the Celery.task decorator. And in the bottom left here, you can see in the run get manifest, we can do run get manifest.delay. So we only have access to that delay function because we've decorated the task with the Celery decorator. So that's a quick whirlwind guide into how to separate your database out, or else failing that, how to use background tasks to update your database. One of the other things I've been working on for a while now is to add in a JavaScript front end. So I found one of the things whenever a user would come to my website, they'd see kind of two things. They'd see a static web page that would have a picture of an item. They'd click on that picture to transfer the item or to equip it, and then the full page would refresh. It doesn't lead to a great user experience, especially if there's a lot of API calls in the background. You're pulling data from databases. It can take all of that can add up, and that's before the page actually loads up on the user screen. So server-side applications are great for two things. They're great for delivering a fully rendered HTML page, but they're also great for delivering a JSON response. So you don't necessarily need to wait to either, well, first of all, you don't necessarily have to deliver a fully rendered page. You can have a JavaScript front end handle the rendering, which is a lot more flexible than trying to do it server-side. And second of all, what you can do is you can actually send out part of the page and then update other aspects of it with an API, so with the JSON API. In this perspective, so I kind of looked at it from two perspectives. I looked at it from React and from jQuery. React is a bit kind of all or nothing. It kind of wants to handle all of the web page, or you need some glue logic to kind of to integrate it in with a fully rendered HTML page. So in the instance on the left here, when I was trying to add a React-based modal to it, it required a lot of glue logic just to kind of get all the event listeners connected up to it. Whereas doing it with jQuery was actually pretty trivial. So I'll take you through kind of a React and a jQuery step through now. So first of all, we have to add the API blueprint. And again, this is all pretty well documented. Especially with Flask now, adding APIs is pretty easy now. So it's done, your app is kind of separated out by blueprints. And in this case, I have an API blueprint. So the API 1.0 blueprint is in the create app function. Once we create that blueprint, we can add data endpoints to that API. So you can see here in the init function, we just create the blueprint. We call it API, and up on top on the very left here, we can see we decorated with the API.root. So again, it's completely separated from your views, so from your rendered web pages. This is just it's just going to return a JSON response. So it's a good idea to separate your HTML views from your JSON data. There's a lot going on in the background of this function here, but essentially all it does is it takes the result from getProfile, which is a Bungie API endpoint. It does a bit of parsing on it, and it returns your character details. There's a bit of magic going on in the background, but what it's actually returning, I'll show you in I think 2 slides after this, but there's still about 50,000 lines of JSON, so there's still quite a bit of parsing that needs to go on after this. Installing React it's not trivial, but it's not too hard either. Actually the React website is a pretty good resource for this, but if you look at the React website, they'll tell you how to install React in 2 minutes, which is great, but it kind of omits the fact that you also really need to install Babel, and you also really should install Webpack as well. So Webpack basically takes all your multiple JavaScript files and packs them together into one bundled JavaScript file, so it kind of optimizes your code that way. And Babel transpiles your code for different web browsers. So in a lot of the code I've done, especially with jQuery, you're kind of creating custom scripts, and you might try it on your laptop, it works great. You try it on your phone, it works great. I have an older iPad at home which doesn't kick off a lot of the modals because there's some kind of browser specific quirk. It doesn't like some of the jQuery stuff. So Babel should handle all of that. It'll make all your code kind of non-browser specific, which is great. And again, one of the things you really don't want to do is when running or when installing React, a lot of people would kind of advise you to use the create React app script, which actually kind of creates your template app, React app folder. But essentially what you'd have to do with that then is you have to kind of look at, you have a new template now, and you have to look at kind of shoehorning it into your existing workflow. So how do you change the structure of your existing app just to fit in React? You don't necessarily need to do that. You can just install Webpack, install Babel, install React, and do npm.init. And you do need to configure your Babel and Webpack files for for your new app, but it's a lot easier than actually trying to shoehorn create React app in. I probably don't have a huge amount of time to discuss it, but if anyone needs help with that afterwards, I can talk to them, and I'll hopefully have some time for questions. So on the left is essentially part of the response that Bungie send me whenever I ask them for data. So you can see here there's 50-odd thousand lines of JSON data just related to the character's profile. And on the right, this is essentially what I'm trying to build with this piece of React code. There's actually a lot going on in the pictures, which for someone who plays the game a lot, I kind of understand it, but for people who don't play the game, you can see the character name. The character level is level 50 and level 30. So I obviously play a lot of my Warlock. I don't really play much of my Titan or Hunter. The character power level is 591 on my Warlock, but 310 and 354 so on my neglected Titan and Hunter. The race, gender and class, so my Warlock is a Warlock exo male. My Hunter is a Hunter awoken female. So again, for people who have multiple characters, they might have two Titans, one male and one female. The images in the background are actually composed of two different images, and the URLs of both of those images come in the response from Bungie. So everything you're seeing here is actually from the Bungie API. So first thing we need to do is add React to your app root, add the React root to your app. And on top here we have the react.html. This is a Flask Jinja 2 template, and there's nothing extraordinary to it. I create the div with the ID display emblem, and you can put whatever you want in there. So it's a good idea to put like a loading icon in there. So if you're creating a server-side rendered web page, but you're updating part of the page with React, then at least you can have some sort of a loading icon as a placeholder. Everything inside display emblem will be stripped out and replaced when my React component actually renders. And you can see on the bottom here is my React component being instantiated. So document get element by ID is display emblem, and then I'm going to put the output of my display emblem React component into that div. So everything will be stripped out. So this is the actual API code here. So you can see here, I've tried to chop it down a bit so it's a bit more readable. Component did mount is the preferred way to interact with it or fetch data from an API endpoint. So you can see the URL there is, my local URL is character details, method is post, and there's not a huge amount else going on there. I'm taking the response, so and then setting this dot set state equals JSON underscore response. So I'm taking that huge chunk of JSON data and I'm storing it in the state called JSON response. And how do I render that component? This is, again, it's a bit of an eye chart here, but you can see kind of what's going on. So I'm mapping through the JSON response and I'm returning the emblem image. So I'm returning a bunch of divs. I set all the class names. I set the styling for the image. So you can see the second div there, div class names emblem. Style is a background image. And that's the URL with the item.emblem path. And again, I'm taking all the character name, the class name, the level, power level, everything out and displaying it up there. Yeah, and so that's the full React code, and actually it's actually pretty simple to get that up and going. You can see the result of that here. So not a huge amount of code for actually writing that out, but it's a hell of a lot more flexible than doing this in React than it is doing it in on the server side and then sending it fully rendered. You also have the flexibility that anytime something changes, you can just update the view. You don't have to re-render the full page, or you can asynchronously fetch that endpoint again and just update that div. You don't have to update the entire page. So that's React. I'm still working on the React side of things. I haven't fully committed to to updating my full website with it, but I'm pretty close. I still do have some jQuery stuff, so I'll take you through a really good example of jQuery. And I think the good thing about jQuery is if you're familiar with jQuery, you know it's really easy to get it up and going. An added benefit is if you're using Bootstrap or, for example, Moment, then you actually already have jQuery included in your project. So you don't have to jump through the hoops that you would need to if you're installing React. It's very easy to get started, and it works very well with server rendered pages. So if you take a fully rendered page, adding an event listener is pretty trivial, and updating a part of that page again is very trivial with jQuery. Whereas again, React can be pretty all or nothing. You kind of render the full web page or the full div with React, or else it can require a lot of glue logic to actually get that up and going. And you can see here on the bottom as well, in my super tag there on my base.html Django script, I already have jQuery included in it, so there's nothing extra needed to do. Just get coding. So this is what the jQuery modal looks like. So when I have a lot of kind of these flat icons in the background, and previously what a person would do is they'd click on that and it'd give them the option to transfer well, it wouldn't really give them an option, it would just transfer the gun. So if you click on that even by accident, it would transfer the gun and fully refresh the page. So I wanted to kind of build on that user interface, and this was actually a really great way of doing that. So whenever you click on an image now, there's an event listener added to that image, and it pops up with this modal. And there's a lot of information, again, on the screen here that it kind of looks like a bit of a fancy picture, but for people like me who play the game, you can see that, okay, this is a gun. The gun is called the Ace of Spades. The fact that it's got a yellow background and a yellow bar going across it means it's an exotic hand cannon, and you can see at the top there. So the exotic is the weapons tier, and the hand cannon is the weapon type, and again, they're all taken from the API. And the icon image and the screenshot are all taken from the API. And the text here, folding was never an option, is the description of the weapon pulled from the API. And on the bottom here as well, you can see I have an equip button and a vault button. So the equip button will actually, you can think of it as taking the weapon and putting it into my character's hand. And the vault weapon is taking the weapon and storing it in the vault. So if my character already has a lot of weapons, you can only carry, I think, 9 of each weapon or 10 of each weapon. So you have to stick everything else in the vault. And something I'm trying to build out then as well is if you have multiple characters, you can immediately transfer them to another character. And again, this was a fully server rendered page, but jQuery made it really easy to interact with this. It was very easy to get it up and going. The modal itself is just a regular Bootstrap modal that's just been added right at the very end of the body of my HTML page. So we'll take a look at what that looks like. Again, so the Bootstrap modal, I've chopped a bit of it out, but really it's just a generic Bootstrap modal. There's nothing special about that. The real magic here is in how easy it was to integrate jQuery and get it up and going. And so you can see here on the top, so document.ready, so we wait for the document to be ready. Image modal.on.click, so we're binding to an event. So whenever someone clicks on an image with the tag image modal, so that's, is that a class? That is a class. So an image with the class image modal is clicked. We get the ID of that HTML element. And then from that, I've added some attributes to the HTML tag. So the icon is stored in the src attribute. The item name is stored in an attribute called title. The first thing we do is we strip any of the previous items from the modal. So we strip out the old header, we strip out the body, and we strip out the footer, because it's the same modal HTML that's been reused with every click of the mouse. So whenever you click on a different item, you have to clear out the old junk data. And then essentially all we do then is we populate it. So so you can see we just add the modal header and body. So $modal header item name, and we just give it the item name that we've stripped out from the attribute before. It's a bit of a chopped down example, but it works really well. Yeah, so this is just a kind of quick and dirty hack that I'd used to kind of hide all the HTML, or hide all of the weapon attributes, or the item attributes, I should say, into the HTML tags. So you can see here on top is the Python code I have for the Django template, and on the bottom here is what it looks like when it's when it's rendered to the view. So I've added in all the custom tags there. And you can do that. You don't necessarily have to do it the way I've done it. You can add in HTML meta tags, or you can do it a couple of different ways. The preferable way would probably be to do everything in something like React, but sometimes we have to kind of make do with what we've got. And right now, jQuery was what I had. So apologies about the technical difficulties at the beginning, but that's how to power up your web applications with your Python web applications. I'm not sure if I have time for questions.
Yeah, we have to run on to the next one.
Okay, but you can catch me outside or catch me down here. So thanks very much.